I got a request to do this problem from the notes. We're going to be writing and balancing a double displacement reaction, but it doesn't give us the products. We're only given the reactants. So the first thing we're given is zinc nitrate. So that's the first thing we're going to have to write out. And Callie's already up here. She's wanting to participate, so maybe you'll get to hear her talk in a little bit. So we'll start with the zinc nitrate. It's important to remember all the charges of all the ions that you're using. Zinc always has a charge of +2. That's one of the things that you had to memorize. And nitrate, NO3, always has a charge of -1. That way, when you crisscross the charges, and remember we had to do this because in order for this to create a neutral compound with no charge, you needed 2 of these in order to counterbalance the 2 positives. So we would just say, well, we can crisscross these numbers. The 2 goes here, the 1 goes here. We don't really have to write the 1. But then you would end up with zinc nitrate. The nitrate would have a subscript of 2, and I like to put a line in front because we're going to end up balancing them. The second compound that you're adding to the zinc nitrate is your ammonium sulfide. Ammonium is another thing that you had to have memorized. Ammonium is NH4 with a charge of +1. And sulfide, anything that ends in "ide" means you just have that element, sulfur, by itself, but in ion form. So it's only sulfate and sulfite that end up having your oxygens attached to it. So if you look at the periodic table, sulfide, or just sulfur when it's an ion, has a charge of, and here's Callie bumping into the iPad, 2-. Just like before, you have to crisscross those charges, and you would end up with ammonium in your parentheses with a subscript of 2 attached to that sulfur. So the big question where a lot of folks get confused is, how do I know what I'm supposed to end up with as my product? Because don't forget, these are just the reactants. It wants to know what we end up with as well. Well, I had students show me a few tricks before, and one of the things that I like the best is you take whatever positive ion you have here and you pair it with the other negative ion. So this zinc will have to go to this sulfur. In doing so, and I'm going to have to write the second half of my equation down here simply because I won't have enough room, but you should just get zinc sulfide. You have to crisscross those charges just like before, but because they're both charges of 2, they automatically cancel each other out, and you really only need 1 of each. Then I'll choose a different color for this next one. You take your other positive ion, your ammonium, and you're going to pair it with the only negative ion you have left, and that's the nitrate. So we're going to add your ammonium nitrate. And the cool thing is, yeah, you can crisscross the charges, but they're both 1. You only need 1 of each, so you have NH4, NO3 right there. That's really what I have been told is the toughest part, is writing that full-on equation, just given the 2 reactants and having to figure out what the products are supposed to be. At this point, I always recommend for students to balance the big stuff first. So if I look at the largest compound in here, I would say this by far is the largest compound. It has the most stuff. And you have your ammonium and you have your nitrate. If you focus on each ion rather than balancing each individual atom, like just looking at the nitrogens, don't do that. Look at the whole thing. Look at how many ammoniums you have. Look at how many nitrates you have. And if you look in the first half of the equation, Callie was just touching the board. That's great. We got to be careful here. You have 2 of each in your reactant. So these are reacting with each other. So in order to balance that out, we need 2 ammoniums. So 2 here, 2 here. And that also gives me 2 nitrates over here and over here. You only have 1 zinc, you only have 1 sulfur, so at this point, the whole equation is written and balanced.